Integration by partial fractions. In the previous session, we have discussed how we can integrate a denominator which is in a product form. That is by splitting that particular product into what? Linear denominator. So if you have linear denominators, you can easily integrate that. So that is what we have discussed at the end of the session. So let's look at more about that, or what we specifically call it as the partial fractions in this particular video. So what is the basic idea which is going behind this partial fractions? I'll just write down a particular fraction 7 by 10. What is a 7 by 10 has got to do with our partial fractions? So now what I'm going to do here is I am writing 7 as 5 plus 2. I'm writing 7 as 5 plus 2 and 10 as 5 into 2. So now I have written 5 plus 2 by 5 into 2. Now can I also write this as 5 by 5 into 2 plus 2 by 5 into 2? Yes. So when I do that, I get it as 1 by 2. I get this cancelled and this also get cancelled. And I also can write this particular 7 by 10, the fraction, as a sum of two separate fractions, which is 1 by 2 plus 1 by 5. This is the basic idea that goes behind partial fractions. So you have a denominator. Here the denominator is not in the form of a product, but still I'm taking 10 and I wrote it as 5 into 2. So when I have written it like that, now it is in the form of a product. And that product or the denominators, I have now split up those denominators into two separate fractions, which makes our calculations in integration very easy. So let's start with an example. The example goes like this. Find the integral of 1 by x square minus x dx. What is the integral of x square minus 1 by x square minus x dx? So as you can see, integral 1 by x square minus x dx, I am writing it as x into x minus 1 dx. So here you can see clearly the denominator is a product of x and x minus 1. It is together, right? Now what is my aim? My aim is to split them. My aim is to split by x and by x minus 1 separately. So do I know 1 by x into x minus 1 can be separated into 2 in any random way? No, I can't split it in any random way. So what I have to do here is, look here. So what I have to do here is I take this x into x minus 1 over here and I write it as something a, I don't know what is it. So a by the denominator. What is the denominator? The first one that we want, x, plus the second one, that is, I don't know what is the numerator, so I put it as b by x minus 1. So if I write this in this form, I can easily integrate. Yes. So what is this a and b? That is the first thing that we have to find out. So to find out a and b, what I'm going to do here is 1 by x into x minus 1 will be written as a into x minus 1 if I take the LCM or if I cross product it. So I get a into x minus 1 plus bx by x into x minus 1. Now both are having x into x minus 1. Let it go. You have a numerator 1. You have a into x minus 1, that is ax minus a plus bx. So you have something in this form. You still have not got the value of a or b, but you have a form where 1 is equal to ax minus a plus bx. Now what you have to do is you have to compare the coefficients. You have a coefficient ax plus bx, that is the coefficient of x is what? A plus b. Is the coefficient of x a plus b here on the right side? The coefficient of x, is that a plus b? Yes. Now, is there any particular coefficient for x on the left side? Is there anything on the LHS? No. So can we write a plus b is equal to 0? Definitely we can write, because on the right side x is having a coefficient, combined coefficient of a plus b, and on the left side there is no x term, so that means the coefficient is 0. So a plus b is 0. Okay. Now you have one term which is left over there, which can be called as a constant because it does not have any x terms. And that term is here is minus a, and here on the left side also you have a constant which is 1. So minus a equal to 1 or a equal to what? Negative 1. So you got a is equal to how much? Negative 1. Putting that over here, you will get minus 1 plus b is equal to 0 or b is equal to what? 1. So now you have the value of a, which is minus 1, and b, which is 1. Can we go back to this one? Yes. So when you go back to this one, you can put this as 1 by x into x minus 1, 1 by x into x minus 1 dx. You can also write as a by, what is a? Minus 1 by x plus b. What is b? we got it as 1. So 1 by x minus 1 dx. Now what is the integral of minus 1 by x? It will be minus log x plus, what is the integral of 1 by x minus 1? Plus log mod x minus 1 plus c. Or finally, you can also write as log mod x minus 1 and minus log x. You can combine and write as log mod x minus 1 by x plus c. So this gives us the integral of this particular function 1 by x square minus x dx, which is done using the rule that we studied, the partial fractions way. We had a fraction with denominator as a product. We took the product, we split them up into different individual parts which can be integrated easily. Okay, so this is one way of doing partial fractions. There are many other different ways of doing partial fractions, right? So what are those different ways? That's what we are going to look now. So the first one is integral px plus q by x plus a into x plus b. If this is of this form, then you have to write it as integral a by x plus a plus b by x plus b. You can see both are linear. See the denominator, x plus a and x plus b, both the parts or the parts of the product are linear. So you can write it as a by x plus a plus b by x plus b dx. Very easy. And the next one is integral px plus q by x plus a into x plus b into x plus a. You have a third one. Or in place of px plus q, you have px square plus qx plus r, something like that. Then also you can also write it as a by x plus a plus b by x plus b plus c by x plus c dx. So this is one way we can write this one, the second form of the partial fraction. So these are two different forms that we have discussed for partial fractions. Third one, integral px plus q, put a dx, okay? Don't forget dx. So integral px plus q divided by x plus a the whole square into x plus b. Here there is a slight change. The first one is linear but having a square. So what you have to write is integral a by x plus a, linear one, plus b by the square form of that is x plus a the whole square, plus c by the third one, that is x plus b, that is c by x plus b dx. So if we write it in this way, you can use partial fractions here also. And the last form that we have here is integral px plus q by x plus a into x square plus bx plus c, x square plus bx plus c. If you have this form, then you have to write it as integral a by x plus a plus this one. The second one is having a quadratic polynomial, x square plus bx plus c. So if it is having a quadratic polynomial, what do you have to write? You have to write not b, not c separately. You have to write as bx plus c. So this is the way you have to write for the third one. That is, if it is in this form, if the denominator is in the form x plus a into x square plus bx plus c, you have to write it as integral a by x plus a plus bx plus c the whole divided by x square plus bx plus c dx. And now you apply or you cross multiply and find out what? ABC. What is the next step that you have to do here? After writing in this form, you have to find A, B, C, whatever. Like if there is A, B only, you have to find these two. There might be C and D also in some cases. So find out all that and go back to the form and split them. And after splitting, what do you do? Directly integrate and get the final integral for this particular function. Understood? Now let's look at an example. So now here we have a question that is integral x square plus 1 by x square plus 2x minus 3 dx. So now you have to integrate this particular fraction. So when you see this fraction, first what you have to do is, while doing partial fractions, you have to check for the degree of the numerator and denominator. Here the degree of numerator is 2, the denominator is also 2. So if the degree of numerator, listen here, if the degree of numerator is greater than or equal to the degree of denominator, then you have to divide the numerator by the denominator. So you have to divide. So here it is equal. So if it is equal also you have to divide. So dividing them, what we will get? Dividing x square plus 1 by x square plus 2x minus 3, you will be getting 1. Because x square when it gets divided is 1. So you have x square plus 2x minus 3 here. and then you put all this minus, you get it as 4 minus 2x or minus 2x plus 4. So that is the remainder that you get, and quotient is 1. So now you can write this x square plus 1, this particular function, as 1, that is quotient, plus the remainder, that is minus 2x plus 4, by the divisor, that is x square plus 2x minus 3 dx. So you can write it in this way. Now when you write in this way, what is the integral of 1? It is x, simply x. But what is the integral of this one? That is minus 2x plus 4 by x square plus 2x minus 3. Can we write x square plus 2x minus 3 as x plus 3 into x minus 1? This is x plus 3 into x minus 1, yes. So if I write it like this, I will get it as x plus 3 into x minus 1 dx. And now you can see that this particular thing can be done using what? Partial fractions. So you take this separately, minus 2x plus 4 by x plus 3. I'm taking it over here, x minus 1. I'm writing it as a by, what is the first denominator, x plus 3, plus b by, what is the second denominator, x minus 1. And now when you cross multiply, you get it as a into x minus 1, or it is ax minus a plus b into x plus 3, or bx plus 3b. So that is what you get, the divided by x plus 3 into x minus 1. You can cancel these two denominators, x plus 3 and x minus 1. And what you're left with, minus 2x plus 4, ax minus a plus bx plus 3b. And from that, you know that the coefficient of x, it is ax and bx. So can we write it as a plus b, the coefficient of x? Yes. What is the coefficient here? Minus 2. So a plus b is equal to minus 2. And what is the constant? Minus a and 3b. So minus a plus 3b is equal to what? The coefficient here, or the constant, that is 4. So you need to find out a and b. So just add these two, gets cancelled. 4b is equal to 2, b is equal to 2 by 4, or 1 by 2. So that is b. Now a plus 1 by 2 is equal to minus 2, or a is equal to minus 2 minus 1 by 2, or minus 5 by 2. So that is a. So you have got now b and a. Put these two here and make it in this form, a by x plus 3 plus b by x minus 1. So when you do that, I'm just going to erase all this. So when you do that, what you will be getting? You will be getting it as x plus, this one is integrated already, x plus minus 2x plus 4 by x plus 3 into x minus 1. You can write it as what? A minus 5 by 2 into 1 by x plus 3 plus b is how much? 1 by 2 into 1 by x minus 1 dx. So that is what you get. And now that is x plus, what is the integral of minus 5 by 2 1 by x plus 3? It is minus 5 by 2 log mod x plus 3 plus 1 by 2 into, what is the integral of 1 by x minus 1? It is log mod x minus 1 plus c. So this gives us the final integral of this particular function. Okay. So what we have used here is how to use the partial fractions. We studied if the degree of numerator is greater than or equal to the degree of denominator, you have to first divide. And now what is the second case? If the degree of the denominator is less than, suppose it is less than. Suppose if it is less than, then what do you have to do? If it is less than, then you don't have to divide, you have to directly apply partial fractions. If it is less than, you have to directly apply the rule for partial fractions. Clear? So these are the different ways in which we can use partial fractions to solve problems. So we have a question over here, integral 1 by x raised to 4 minus 1 dx. So this x raised to 4 minus 1, I can write it as integral x square minus 1 into x square plus 1 dx. Yes. And also this 1 by x square minus 1, I can write it as 1 by x plus 1 into x minus 1 into x square plus 1 dx. So, okay, this is one way that I can write. Now I need to split the denominator. So I can split that by writing a by the denominator x plus 1 plus b by the denominator x minus 1 plus, what is the last one, x square plus 1? I can write it as cx plus d, because according to the rules of partial fractions, I should be writing it as cx plus d by x square plus 1 dx. My aim is to now find out what is a, b, c and d. Now you can see that I need to take the LCM. So I'm just writing it over here. 1 by x minus 1 into, x plus 1 into x minus 1 into x square plus 1 is equal to a into x minus 1 into x square plus 1 LCM plus b into x plus 1 into x square plus 1 plus cx plus d into x square minus 1. So these are the different things that I get here. Now if I multiply all this, I will be getting a into x cube minus x square plus x minus 1 plus b into x cube plus x square plus x plus 1 plus cx plus d, that is cx cube minus cx plus dx square minus d. And on the left side you have 1. The denominators gets cancelled because you have taken the LCM, right? So they get cancelled and you are left with 1. So when you are left with 1, this 1 is the only constant. So now look for the x cube terms. You have a, you have b, you have c. So what is a plus b plus c? That is equal to 0. Now look at the x square terms. You have minus a, you have plus b, you have d. So minus a plus b plus d is equal to 0. Now look at the x terms. You have a, you have b, and you have minus c. So a plus b minus c is equal to 0. Now look at the constant. You have minus 1 into a, that is minus a, plus b into 1, that is plus b, and then you have minus d, and that is equal to, the constant is equal to 1. So you have a plus b plus c is equal to 0, minus a plus b plus d is equal to 0, a plus b minus c is equal to 0, and minus a plus b minus d is equal to 1. So now what I'm going to do here is, I'm going to take this first one and the third one. So a plus b plus c is equal to 0 means a plus b is equal to minus c. A plus b minus c is equal to 0 means a plus b is equal to c. So that means when I take these two, I can say minus c is equal to c, or 2c is equal to 0, or c is equal to how much? 0. So c value is how much? 0. So c value is gone. Now you have the second one and the fourth one. So when I subtract these two, when I'm just subtracting these two equations, this minus a plus b and minus a plus b gets cancelled. D and minus d, when it gets subtracted, you get 2d. 0 minus 1 is minus 1. So you get d is equal to how much? Minus 1 by 2. So d is equal to minus 1 by 2. Now from putting the c value in the first one, I get a plus b is equal to 0. And putting that d value here, minus a plus b, I'll be getting minus a plus b is equal to minus d, or it is equal to 1 by 2. Now if I just simply add these two, these gets cancelled. 2b is equal to 1 by 2, or from this I get b is equal to 1 by 4. So what is the value of b? I get it as 1 by 4. Putting that b value on a plus b is equal to 0, I get a is equal to how much? Minus 1 by 4. So you have a minus 1 by 4, b 1 by 4, c how much? 0, and d is how much? Minus 1 by 2. So a is minus 1 by 4, b is 1 by 4, c is equal to 0, and d is equal to negative 1 by 2. So there is a value of a, b, c, and d. Now putting that all back, you get integral minus 1 by 4. What is this first one? X plus 1. So minus 1 by 4 into 1 by x plus 1 plus b is how much? 1 by 4. So 1 by 4 into 1 by x minus 1 plus cx plus d. 0 into x is 0 plus d is minus 1. So minus 1 by 2 by x square plus 1 dx. So that is what we have. And when you integrate, you will be getting minus 1 by 4. What is the integral of 1 by x plus 1? Log mod x plus 1 plus this one is 1 by 4 into log mod x minus 1 minus half into, what is the integral of 1 by x square plus 1? It is tan inverse x plus c. So this, or finally you can also write as 1 by 4 log mod, combining these two, log mod x minus 1 by x plus 1 minus half tan inverse x plus c. So this is the way you have to find the integral for the function 1 by x square x raised to 4 minus 1 dx. So this is all about partial fractions. You have studied in the previous videos what are the different types of integration, which started with substitution, then trigonometric functions, and now we studied partial fractions also. There are more methods of integrations that will be followed in the upcoming sessions. Until then, keep exploring.
Manorama Horizon. Learning made simple.